Okay, great. Now, so this was the second one, which we discussed, which we haven't gone through all. Yeah, Prasanna, I got your email. Okay, I have gone through it. It is fairly okay from my side. Okay, I'll pinpoint the exact points in the email itself and discuss with you. All right. So, all right. And in case required, I'll let you know that if we need to do a discussion separately. All right. So now there was a second problem which I left you with in the session three. The idea was that given a large corpus of text, large corpus as in terabytes of data across the crawled data from the Wikipedia, say. Now, given a large corpus of text, you have to figure out the top five recommendations of the word that would go next. Say, if user types happy, you need to give the next word which has appeared in this corpus of text after happy. And in case it's a fairly generalized one, so it might be birthday, new year, marriage, or whatever based on the actual data. So that was the one problem. And there is a large corpus of text available from the people like Amazon. They have a public data set available, which you can take a few, say maybe 5 GB sample out of that one and try to run this one. Okay. Now, how many of you thought about this problem, and how would you, build this kind of a solution? So, did anybody try to attempt this one? So is the question clear to you? If I mean, if the question is not clear to you, just let me know quickly. I can repeat it. Okay, 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 okay. So, right. So I will just describe my approach. All right, and then let me see if you can, figure out errors in this approach. So, say for example, we have a text called "How are you, Ram? Happy birthday to you." So the line ends here. These are three lines. First one starting with how, second one Ram, and third one is to. So you have got this text. Now you need to figure out your problems with it. Okay. So this is the text. So the general approach I have taken here is I converted into each two words into a uh, you know tuple. So I formed how as the key and R is the value. Then R is the key, U is the value. That's it. Now next line again, take each word and its next word, and then and do keep doing it. Keep on reading to two. I mean two words at a time and one word at a time, and then keep on printing previous word plus current word, and you get this kind of thing, right? Now when you run a when the Hadoop executes your mapper, this is the output you will get. After that, it will sort it, and you know, you'll do the frequency analysis, like what are the top 5 words you will get and all. Or you can do other way also. You can make how dash r as the key and put one over there, r dash u, and then put one over there, and then let Hadoop prepare the frequency of this one. And okay, and then what you could do is you can after you are done counting the frequencies, you can do another mapper and figure out only those whose frequency is greater than some value, right? So, hope you got the picture now. Did you get the picture here? What I'm trying to do? There are two approaches to it. Okay. The first one is simply I've made first word how, and what is the next word that will come after how, then are, the next word what will come after are. So how are you becomes how are you, and then Ram, happy birthday. So Ram, and then happy birthday to you. So what is the mistake over here which I'm doing? What are the problems do you foresee in this one? Or will it be just perfect solution? Anyone? Ishwar Jagannath Karthik Pranav Prasanna. So this is the way I'm trying to create this. Basically, the overall objective is find out what are the top 5 words that come after a particular keyword. To do that, I've made a particular keyword as the key and the word that follows as the value, and that I do for all the words. Now, when a sorting happens, when Hadoop does a reduction phase on this, you will get a all of the values, so all of the words following how will be aggregated together, right? Now you can run a frequency analysis on that. So that is the approach. So do you see any problem at all? Is it perfect? So just give me some sign that right. In the reduce phase, it will not provide top 10 words. Instead, it will just provide you a list of words, right? And now in that list of words, you will have to again find out somehow. That will become very, very problematic. Okay, because you'll have to do. Okay, so you are right, Karthik. Anybody else has a point here? Okay, so any questions over here, or is it perfect? Just keep responding, yes, no, or maybe. That way I know that you are there or you are able to hear me. Can you hear me? Okay, okay. So Pranav, Pranav, the problem is clear to you here. Basically, we given a corpus of text, we have to find out the we have to find, and this corpus of text may be 10 terabyte. Okay, so we can't generally use a hash table or local solution. We are trying to use a MapReduce kind of a phenomena to do the MapReduce onto this corpus of text. Okay, so let me just go through the various problems myself, right? So first thing you will see that the last word of the line should pair with the first word of the next line. Like you has to come here because you Ram is following you, right? So after you we should have one pair Ram. But since mapper is being executed line by line, that is not possible right now. Now second one is the last word of the sentence should not be paired. Here we have paired Ram with Happy. Okay, so we cannot pair that because Happy did not really come after Ram, because that's a different sentence altogether. Second, the computation of frequency should be further map reduced, because it's itself is a difficult task to do it in memory, because there'll be lot of words after how or these things, so maybe millions of words after few words such as is, right? So either we remove the frequently occurring word like is, am, are, okay, or do a proper map reduce instead of doing it in memory here. So these are the three problems. We will discuss first two problems, how to solve it using advanced map reduce, and then we will go into a little bit deeper into what is, how can it be done. All right. Yes, so we can provide a list of words which need to be skipped, right? But that also will not be a solution alone, because I mean the frequency analysis should be done properly, in the sense that you can either form the key based on the tuple together, right? So third problem can be solved by either of the techniques, but first two problems, let's say you and Ram has to come together, and birthday and two has to come, have to be formed, the pair need to be formed, right? So I mean to say that the way mapper works is by breaking the default mapper breaks the text into line by line, right? Line by line. Now what if we have to break the text sentence by sentence? That is the agenda. Okay, so we need to figure out, can we tell MapReduce by the way of Java or any other mechanism to break the line, break our whole corpus of text into sentence by sentence, and our mapper can operate on sentence by sentence. I mean, mapper should operate upon a sentence at a time instead of a line at a time. Now, how do we do that? That is the big question, right? So that is what we are going to discuss today. So, I mean, very, very quick question as a recap also. The data generated by mapper is given to reducer and then it is sorted and shuffled. Yes, no, quick. This everybody should be knowing. The data generated by mapper is given to reducer and then it is sorted. Is it right or wrong? Karthik? Are you sure? Is it yes? Karthik, I think, uh, you know, I mean, you missed the question here. It's easy to misread this question. Yes, Prasanna is right. It is sorted before giving to reduce. Right. Pranav is saying that before reducer it is sorted. And then Jagannath is also saying mapper sorts before. Perfect, perfect. So, Karthik, are you clear about this? No. Right. During pipelining, it will be done. Yes. So before giving to the reducer, the data is sorted by Hadoop. That is the one of the important job of Hadoop. Basically, that is the job of Hadoop. So the output of the mapper is first shuffled and sorted, and then reducers are called, or the data is handed over to. The mapper can generate a single key value pair for an input value. How true is this? It's another question. Only single key value it can produce, or it can produce multiple key values. Prasanna, do you remember our one record in case of DNA problem generated two records in somebody's example? Right, right. So the mapper can generate it's a false statement, right? So even for a single line, you remember our word count? When we were going through line by line, the whole line was generating multiple key value pairs, right? So if a line has 20 words, then it will generate 20 key value pairs. So it can have any number of keys for an input value or input line. All right? Is it clear now? Great. So you remember our word count example where there was a whole line and line was broken into key value pairs. Key was the word and value was one, which means a single and input was generating more than 20 key value pairs. Okay, another question. By default, there is one reducer in the case of a streaming job. Yes, no, and this one. So by default, there is only one reducer in case of streaming job. Okay. So is Ishwar correct? Yes or no? Okay. Okay. So for a streaming job, by default there is a single reducer. Okay. And but that can be solved by marking that a streaming job to be having multiple reducers. All right. Okay. So now another question to you guys is, what is the role of a job tracker? What is the role of a job tracker? Executing MapReduce job or delegating it? Excellent. Excellent. So everybody is good. Then the map logic is executed preferably on the nodes that have the required data. Yes? Okay? Great. Great. Now some more questions. The whole chunk, the whole chunk is available on a node is fed to the mapper. Yes or no? This is some question which I doubt you will be. Okay. So I'm putting question marks so that I can differentiate that your answers belong to which question. Okay. So the whole chunk. So when we talked about HDFS, we talked about the file being split it into exact 64 MB sizes, size chunks. So say you have got first 64 MB on one node, other 64 MB on another node. So when your mapper is executed on that particular node having first 64 MB, so do I I mean, is exact 64 MB fed to your MapReduce code, or uh, uh, I mean, does it do anything else? What does your gut feeling say? So the whole chunk available on HDFS, or you can say data node, is fed to the mapper. Yes or no? Quick, just give me a hunch. Why do you think so, Pranav? Okay, right. And Ishwar, you are also guessing, or you are okay? You are guessing anyway. You have confessed already. Okay. And anybody else? So I mean, let's just think about the problem we just had, where we were talking about line by line values being fed to the our mapper, right? Right, right. So Jagannath is correct. I think because mapper is run on a node, hence the total data should be fed. Right. 64 MB is default size. So when we store the data, so the data node doesn't care about whether the line is completed or not, okay, or the word is completed or not. It doesn't care. It just slices the data on that particular byte, right? So if a line is half of the line is one chunk and another half is in another chunk, right? But mapper, when we talked about mapper, the default behavior of a mapper is that it will get a whole line from HDFS. Okay. So when the half of the line is another one, another data node, and half of line is this side, the whole chunk cannot be fed as is to the to your mapper code. All right. We will go into the details, and and then I'll ask you if you understood that this aspect or not. Okay. So I'll talk about this part, like input is split using input splits, part of which is transferred to other mappers. Okay. So we have now two questions to answer. First, how will we solve that keyword problem, the one which we started with, where we were trying to feed sentence by sentence to our mapper. That was the objective, instead of line by line. So you understand, right? Sentence by sentence, what does it mean? From a dot, a full stop, to another full stop. And line by line means, this the sentence by sentence means from one dot to another, while line by line are separated by the new line. So if you have to change the way Hadoop works by default, you'll have to do some little bit of tweaking here and there. So I will talk about few things called input splits, okay, and then we will talk about more details into it. All right. One more thing I have before I move on. Where does Hadoop store the result of the reducer? In HDFS or on local file system? This you can answer. Are you sure? The result of reducer, not result of mapper. Pranav, are you sure? Because we are talking about, the results of reducer, not the result of mapper. Do you remember the file which got created onto HDFS when we did our processing? Right? Part dash 0000. So that was on HDFS. That was the result of the reducer. The question is framed such that people think that we are talking about the other one. Where does Hadoop store the intermediate data, such as the output of map tasks, in HDFS or file system? This you can answer. Right, this one is on file system. And why is it so? Anyone? Why wouldn't it utilize HDFS for keeping the intermediate data also? Anybody else? So, okay, let me put it this way. So, whatever your output of the mapper, it is generally sorted and stored locally onto that node. All right, and then it's taken up and given to the reducers. So, why is it done in the file system? Anybody? Or you want to ask me? So it is done on the file system because this data is anyway intermediate. There is no point in uh, you know transferring this data to a SDFS. HDFS will unnecessarily create its replica and all that thing, right? The parent data is anyway in the HDFS. So therefore, it doesn't make much sense to store the intermediate data onto a particular data node, onto a particular HDFS. So today we are going to talk about a little bit about MapReduce in Java. This is the session where we talk a little more about Java, and you will understand why do we need to do that, so that you can plan accordingly in case you have to do something related to a little bit of advance. And what does it mean by advance, I'll be talking today. So right, so here, so mainly the MapReduce under the hood is actually written in Java. Okay. And similarly, to customize MapReduce, the most comfortable and most supported language in Java is Java. Okay. And these are the few steps to start working with MapReduce in Java. First is install Eclipse, create a Java project, add these library called Hadoop MapReduce client core, Hadoop common, and change JDK from 7 to 6, and change the compiler. Okay, let me see if the project is available on the my courses part. What is going on? Okay, I'll look into it. Probably some upgradation is going on. That is why the server is slow a little bit. Do you guys also facing this sloppiness today when accessing the courses, or is it me only? Did you also face this slowness, any of you? Okay. So probably the server guys are doing some upgradation or something. Okay. 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 So it's only me. Okay. Okay. So we're going to talk a little bit more about Java today. And then, so these are the few steps you need to do. First is you have an Eclipse. Here I have a Eclipse locally installed, right? And then you create a Java project over there, add these libraries. Okay, ideally whatever is there in the project, just add that into your library. There's a project available. I'll have to make it available for you guys. Okay, so basically you download that whole zip which will have these libraries which you can add them, and here is the actual code. All right, so I'll go through the code here first and then we'll run the whole thing. So the way you write in Java is you write a mapper. We talked about it partially last time. So uh, Pranav, do you want me to go through it or you are okay with it? Because I've gone through it last time in the previous session itself. So do you want me to go through it or not? Or you are okay with it? Or should I just run a demo straight away? For others, should I go through it once again in case you want? I think let me just go through it. Okay. All right. So we have got, say, a mapper class, stub mapper. It's just my class name, whatever I give it. It basically extends a primary main class called mapper, and here we define the data type such as, you know, the byte offset. So this is fed by the MapReduce itself. I mean, Hadoop itself. So this is byte offset as in how many bytes this line is coming at. So it is giving you the byte offset. Byte offset as in byte count, byte count in a file. So this is nth byte. Nth byte. This line is nth byte from the beginning of the file. Right? And then you have got input line called text. And these are the two things which are the data types which basically dictate the data types you will give out your key value pairs. Okay. So in the map, you will have exactly those two values as the input here. And whenever you are writing to the context, it will be exactly to those data types. So here we are saying that read the line from the input. So this is the line which has come in. We are splitting that line by tab or space, any number of those. So how many of you are aware of regex? How many of you are aware of something called regular expression? We discussed it earlier also. So did anybody, those who were not aware, did they go ahead and looked into it? What is regular expression? Great, great, great. So if you are not aware of regular expressions, make sure that you learn it. It will go a very long way. It will be very useful to your common life also. You will be able to do a lot of data manipulation regularly. Okay. So make sure that you go through the regular expressions. It is quite useful to do a pattern recognition and replace, substitute, and all of those. So value.to is string and then split by this. And so this is what is it in general. And then it will basically split your string or your line with a space, and then you iterate over it and you give out key as the word and value as the number called 1. Okay. So word 1 is tab 1, word 2 tab 2, in that format it will go out, right? Then you write as reducer. Basically, reducer will take the input from your mapper. So note that the data type, this one is the key. This one is the values data type. The keys data type is text, which is normal text, and the value is the key value pairs which will be fed to your reducer are actually coming from MapReduce, and therefore the value is that long, which means that one which we have given out will be given to you. Okay. So here basically your reducer. So this was the data type of inputs and output it will be giving, and reducer is actually a function where you're given key and the array of your long writables, right? Array of long writables. So you have got this in place, and then what you do is you iterate over long writable values and then sum them up and then write to the context. Okay. It's like saying for each key, we'll sum up all the values and give out. That's all. So whatever, you know, for each word, there will be an array of ones coming in. There is a long array of one coming in, numeral one will be coming in, and then this reduced code will basically combine that together and then run it. And this is the main step driver. All it does is all it does is basically create a job and then set the mapper. This is the most important line. Set the mapper class, set the reducer class, and that's it. All right. And then it runs that job. Here you define what is the file you are providing. Here I'm saying do a input path should be arg0, which means whatever, when you are running your job, whatever you provide on the command line will be taken it up as is. For the first argument on the command line goes as input path, and the second argument on the command line goes as the output path. All right. So this is how it is done. Now the next step. So once you have written it, so like here I have written this code already. All right. It's the same code. It has more commands. It has got those import package definitions, and you have got all of this. Basically, this is standard way. And then once you are done with it, what you do is you say export. Okay, you say export, and you say jar file next. Okay, and here you say okay, and yeah, now you generate the output. All right. So it has generated a class over there, and so this whole project, whatever I have done here, is available in the library, along with it is available on the LMS. I'll make it available just after this class, and also it is basically the libraries. All the jars are also available in that zip file. So once you have done it, you have exported it. Now I will copy it. I will say SCP. My this is remember that this is on my local machine, and it was under the name of training 2. I say student at Hadoop 1 dot no. Can you see my screen? Should I increase my font? I think so, right? So I'm saying SCP. SCP means secure copy, and then you can say I mean this is copy over SSH. Remember that, and then okay. Is the font okay? Good, good. So now the next step is that I say I'm uploading it to the server. Oh, not this way. I need to keep it this way. So, so it is asking me for password. Now, so you can do Control U on the command prompt so that things get cleaned up. Control K means delete everything after the line. Those who are not handy with these shortcuts at the bash will find this thing very useful. Have I forgotten the password? Something is wrong with that machine. And yeah, I mean, no, I know the password. It is just that somehow it was giving the error again and again. All right, now it is working. Need to see if I think, okay. Maybe I'll create separate login for all the students instead of sharing the login across. And then maybe the things will be smoother. For the way I have done for projects I have created a separate account for all the people so that their work does not get mingled up. So when you're working, you just create your own folder over here, and then it should be fine. So you can see that training2.jar has been uploaded here. Okay, and something is wrong. These are a few of my servers. So I'm just checking my servers right now. And so why did it happen? Okay. There's something seriously wrong with the machine, and I need to immediately look into it. What exactly is wrong with it? I'm just restarting it for now. So restarted it. So the way to debug generally is to look at the CPU usage, and it should give you a good enough CPU usage. Hmm. So once you are done with your writing all of these classes and exported your jar, you can copy it into the server and then run it simply like this. Okay. In the detail example here, okay, you can run like this. All right. And in case there is a library which you are using other than the standard Hadoop libraries, then you can use minus use lib to copy the jar onto all the nodes. So most of the jar which we are using right now are there with Hadoop, right? So we don't have to copy those jars anywhere. But in case you are using a special jar, basically a special library which is not there with Hadoop, you can use because when your Java your MapReduce will be executed on each individual node. So what will happen is that I mean those nodes may not have that library and will not have a library if it's your own custom library, right? So therefore you need to copy this jar file, which is a library on which your code depends upon, onto all the nodes. But that is too tedious, and it's not, it will take a lot of efforts every time, and it will also spoil your Hadoop lib folder. Therefore there is a way to make it copy the make it there is a way to make it copy the data onto other places. Okay, make it copy the jar file, the lib file, onto using this function. This is similar to when we talk about dot jar or library. Is it equivalent to saying that DLL in case of Windows? That will give you a good idea. So that particular DLL may not be available on that all the nodes, and therefore if you use this flag called uselib, that should be good enough. Okay. So, so question Iswar has a very good question. He's saying that why to move from Java 7 to Java 6, right? So the reason is that when you are running on cluster, so generally the way you write your code on the minimum supported library. So if you have written your code for Java 5, it will run on Java 6, Java 7, and so on, but not vice versa. If you have compiled your code with Java 7, and in case on the cluster the Java is 6, right? So your code will fail there. Okay, so therefore you always plan for you plan your code. You should always compile your code with the most popular JRE at that time, right? So in case I'm launching this product in had I been doing something in 2005, I will go for a Java 4, not even Java 5, right? So that is the reason. So there's a general practice. There's a general practice to do these things. Java supports for n plus 1 only, I guess. No, actually, even if you write your code right now, because here on server we have Java 7. Okay. So it is okay to do it in Java 7 also. But But as a general practice, general habit, you make you make sure that you code against the most popular JRE at a time, or Java SDK at a time, right? So sometimes they even support Java 4, Java 5. I mean, they might keep on supporting Java 6 for a long time. Okay. Okay. Now say I'm running Hadoop jar and say training, and now it will say that you don't have data, and I can say word count and then input. And similarly, asgiri word count and then output, right? And both the folders are from Hadoop, right? Here I forgot to mention one more thing. Just after mentioning the library, you need to tell the entry point. Okay, so you have to tell the entry point, which is stub driver, and in my case it will be com dot no big data, then dot, just to keep it clean, I have gave it a namespace, right? Com dot no big data, right? It's not taking. Okay, so I think this guy is not listening to me. Instead, what I'm going to do is now here you go. So probably somebody is bothering it a bit. So I'm changing the password for time being. Okay. All right. So I've just kicked out everybody from the server. So I can say Hadoop jar training com dot no big data dot stub driver, and then I can say asgiri slash word count slash input, asgiri slash word count slash output. Okay. Okay. I think I think let me just skip this part now. So all okay, no, you carry on, Karthik. Okay, you carry on. And yeah. So basically you need to execute your Hadoop jar this way. Okay. And right now, for some reason, the whole thing is not working probably again. Because right before, just after the session ended last time, I had made sure that everything works as is. And then something is wrong today. Something is seriously wrong now. None of these things are actually working. And I need to just debug it. Okay. Okay. All right. So for today, I don't know what is going on. Anyway, so we can proceed with our lab maybe later. Maybe some emergency is going on over the servers. I need to talk to the server guys. All right. And because I had tested everything in afternoon and things have been working pretty well. So let me try to do it again. No worries. And okay. So other thing is that when you are using the external libraries in case of Java, you can say libjars equals this comma this, and then you can say Hadoop jar my whatever your jar is there, then your class name, then say minus 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 libjar, and then you can say all of this. Okay, if you have single external library, then you can use minus use lib. If you have multiple libraries to use, then you can use libjars. That's a nice way to do it. Earlier, before libjars was there, it used to become a very, very big issue to use multiple jars. We used to flatten multiple jars into a single jar and then run the code. Okay. So earlier that was the mode. Now it is, I mean, using libjars, we can use multiple libraries. All right. And yeah. Okay. Now we have, okay, all right. Now let's just, I will take a break maybe in next 15 minutes. So actually I seriously want to give you a demo today, and for some reason nothing seems to work. Okay, let me just see it later again. Maybe my net connection is not working or something. Okay, I'll do it maybe tomorrow. Tomorrow anyway we have another session, so no worries. So let me just move on to the next session, next portion. Now in case of Java, in case of if you are using streaming jobs, doing a testing was pretty easy. So you do cat file and pass it to your mapper code, mapper.python or mapper.sh or mapper any binary, and then use a command called sort, and then pass it to your reducer code. That was pretty easy when you were testing the MapReduce via streaming job. But in case of Java, they have provided a really, really beautiful way to test your code without uploading onto the server or without using any manual labor, right? So you don't have to do anything but writing the test case. So here you will write the test case saying, uh, you know, this is the general code which you will write always. Here you will say that this is my mapper, this is my reducer, and this dummy driver will be mimicked by the test suite. So sort of you can think of that Hadoop is being mimicked by the test case suite, which is JUnit, and then you can simply run, test case. So for example, this current one, we have got this test case. It does test a couple of things. Okay, here it does that. I mean, this is what I'm putting in the input. Say I'm putting in the input. Sandeep Giri is here. Teach the map reduce and all. And when I run it, it should give us something. Even though I have no Hadoop running on this machine, I can, uh, you know, uh, run my code using using my JUnit test case. Okay. Specifically, as you just saw that I'm not able to demonstrate you using my server or using my actual Hadoop installation, we can run it as a JUnit test case. Okay. Okay. So here, if you see that test reducer says that please implement this. So I have myself put it to fail. Okay. Similarly, here I've put it to fail. While this part I have coded, and there I've also printed out the result, and you can see that it has actually done its job. It has counted number of is, right? The is total number of is once here, other here. So it has counted that, while everything else has only came once in the text. So basically, JUnit test case has done all the job of helping you test. So the idea, the if you are a Java programmer or any programmer, or even the you are into SQL or any kind of developer role, you should always build the test case before writing any piece of code. Okay. And once you have built the test case and you run the test case again and again automatically on that code, it will keep on failing, and then your role becomes, as a part of coding job, your role becomes that your test case should work, right? As you keep on writing or implementing your code, your test case will finally run all of those. So that's a you always code against your test cases. Okay, so that's a general way of general strategy of when you are planning for any development. And here you can see that this has done the MapReduce job here itself. All you had to do is tell MapReduce driver that this is my input, and it gave us the output. After we said MapReduce driver run, it ran our MapReduce engine locally and then gave us the result. Okay, there is no other use of this. Don't try to use it in production. It is just for testing on smaller inputs. Okay, just for testing on smaller input, so that you don't get surprises in the production. Because if there are, you keep on uploading onto server, keep on testing it, there are high chances that you will end up harming your cluster or harming your servers. Also, your development pace will get reduced. Therefore, it is a common strategy to run it locally. All the test case you keep on running on the same machine. Okay. Now the next one, this is the how to create the test case, and these are the what I have just demonstrated in there. Now the next point I want to discuss is the input splits. Okay. So let's take a 10 minutes break. Okay, let's take a 10 minutes break and come back at uh, 10:05. Okay, okay, okay. Before going onward to this topic, okay, let's meet after 10 minutes and then we carry on. Hello. Yeah, I'm back. So are you guys back? Great, great. I'm a little slower, not speaking too loudly today. I've been talking whole day and I've been driving in Bangalore. So that's why my pitch is a little lower today. I'm actually wondering what has gone wrong with my servers. Are they doing some sort of a maintenance which require. I need to evaluate this part. Is it the same story with the other servers? Something wrong. Something universally wrong with it. Never mind. So I'm carrying on. After the session, I'll look into all those things. So today I want to discuss a few more things. One is Hadoop splits, and a demonstration is due. So maybe tomorrow, the first thing we'll do that. So, so there's something called Hadoop splits. I gave a brief over here when I was asking you this question. Uh, this one, okay, and yeah. Right. Input is split using input splits, part of which is transferred to other mappers. So now I'm going to talk into detail. So Hadoop divides input into fixed size pieces called splits. All right. One mapper instance per input split. So when a file is divided into chunks. Okay, as file is divided into chunks, Hadoop creates something called an input split before starting to launch your MapReduce. It creates something called an input split. Okay, input split's sole objective is to figure out how much data need to be given to a map at a time, whether it's line, whether it's something else, that is decided by input split. So by default, input split gives a single line at a time, separated by new lines, right? And so for each input split is corresponding to each chunk, but not exactly identical, right? And for each input split, one mapper is created, and then one mapper is run again and again on that data inside the input split. Okay, so one input split is that fixed size piece called, so the over a chunk of files or over a chunk from HDFS, input split is created such that one mapper can be run on top of this input split. I'll describe more into this. So in case your input splits are too small, okay, And input split is made up of multiple records. Now you can think of input split as a bunch of rows of a data, and each record as a single row, and a mapper is applied on each row, while mapper's instance is created for only once for these bunch of rows. Okay, so input split corresponds to, a bunch of rows, while a record means a row, and a mapper is applied on top of a input split, right? And why is it done? Because the chunk itself is, useless or meaningless for a mapper, because mapper needs a set of data. The way we have been running so far with mapper is it needs lines, right? So those lines need to be full lines. It should not be that the last line is only half. The half is in the next chunk, right? So to do that, before running the mapper, it creates something called input splits. Each input splits contains the records, and one record is given to map function once, and this happens for all the records, but the mapper's instance is only created once to make it really fast for that machine, for that input split. Okay, so the ideal split size, or the ideal input split size, would be equal to the HDFS block. If you create more small splits, okay, then that means there will be too much of overhead of data transfer. We describe to you again, okay. And then Hadoop tries to run the maps close to the where input split or the data is located. If all nodes hosting replica of a data is busy, then mapper is executed at the same rack. If not possible on run on the same node, it tries to run it on the same rack. If not on the same rack, then off rack can be used. Okay, if all the nodes are very busy. Now, what is the difference between chunk and input split? Let me again describe it. Say you have this. These are block boundaries. Okay. So say 0th byte is starting from here, and 64 MB is ending here, and then 128 MB is here, and so on, right? So you have got three chunks from this point till this line and the bottom side of it, and so on, right? Now these, if a file is halfway through there, okay, so so say there are five lines: first line, second line, third line, fourth line, fifth line. Now mapper has to be run on a single line. Okay, mapper has to be run on a whole line rather than half of the line, right? Therefore it makes a lot of sense to basically either let this fifth line be counted on the uh, into this split, or let the fifth line to be counted in the other one. Okay, therefore input splits are created such that mapper gets a whole record to process at once. Okay, otherwise this is completely meaningless. Imagine that in the word count example, our word is split in half of the word on the left hand side in one chunk, and half of the word is in another one, and therefore the single word is counted as two, which could have been a disaster. And therefore the whole idea about input split. So let me take another example to explain what is input split. Say you had three lines. First line 25 MB, second line another 25 MB, and third line is also 25 MB. So chunk 1 will have first two line in whole, in complete, 25 plus 25, while line 3 will be split into two sizes. First First 14 MB of the line 3 will be in the first chunk, and rest of the line 3 will be in the second chunk. Now, when mapper runs on it, okay, so the half of the line is with this mapper, while uh, rest of the line in another mapper. That becomes a very big problem, and therefore an input split is created such that this data on the chunk 2 get transferred onto this data node as and when required, and the whole line is processed by the mapper properly, right? The whole line is processed instead of half of the line. So is it clear to you guys what is the objective of input split? Why do we require input split? Why is there a philosophy called input split? Yeah. So this is what I'm talking about. When I say chunk 1, chunk 2, there are high chances that chunk 1 and chunk 2 are on different nodes, which means line 3, half of the line 3 is on one node, half of the line 3, rest of the line 3 in the another node. Okay. So this is what I'm talking about. Alright. So in these cases, before even starting the mapper, input split is created such that the whole input is properly processed. Right. So an input split makes it possible a sort of a view on top of the chunk. Okay. Input split is sort of a different view on top of the chunk where the basically most of the data I mean some of the rudimentary data parsing happen on the input split level, and then it basically your chunk, which is bytes as stored on the disk, are converted into records and bunch of records. So similarly, if you so basically you can extend so you can basically extend a class called input split. If you want to create your own kind of, say, we talked about an example. So by default, input split, the default input splitter, basically the each record is a single line, and a bunch of lines are a single input split. Now, say the example we gave earlier, in that example, a sentence, a sentence is basically we want a sentence to be a record, meaning our mapper should get the whole sentence only at a time. Now to do that, we have to make sure that sentence does not spill over to two records the way we had. So we can do all of that very, very neatly by extending or implementing input input split. Okay. So first you define something called input format. This input format is given an input split, and you create a record reader. Record reader is basically gives a record by record entries to you, and similarly uh, you know splits also. Where are the splits located? And here you define something called input split, where we can use a where we can implement this, both of this. Alright? So that is how it is done generally. Okay. Okay. So basically, by extending input split and input format, you can parse the input data in your own fashion. And Hadoop provides it very, very neatly that you want to read a file till a offset and then leave it, and then the rest of the portion will be read by another data node, and so on. And that is how the whole function starts. So you start at a point, keep on reading till the sentence finishes, and then let the another one read it. And that is how the whole input split input format works, right? Is it clear to you guys? No. So see, we need to process each chunk. We want to take a benefit of having the data locally, right, on the same data node and task tracker. But because HDFS doesn't know anything about your data, so HDFS has, sliced your data with a hard limit at 64 MB, and therefore the data may not make sense on a single node. Okay, because half of the record is this side, half the other side. So therefore, Hadoop provides you a mechanism to customize it. Although by default it does a line by line parsing very very decently. If you want to do some other kind of function which rely on things like, say, I want to process sentence by sentence, specifically when you do sentiment analysis or grammar checking, you need sentence by sentence or paragraph by paragraph, right? So to do that kind of functioning, to 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 dictate to Hadoop that, hey, I want my input to be in this format and this is how I want. It provides you these functionalities called input split and records. Does it make sense to you guys? Iswar, is it clear to you guys? Yeah, this is the only portion which is only in Java. Alright. While your MapReduce job, the way you run the job, can be done in other languages. Alright. So again, a record is basically each input split is further divided into records. A record is an equivalent of a line or a row. Okay. And a map function at a single time is applied on a record. Okay. While the instance of the mapper is created only once per node, which means once per input split, and record is basically a logical entity. It has nothing to do with the block size on the hardware or on the file system level. No, it is a logical entity which makes sense to your mapper. When your logic says that process a sentence, then sentence is your logical entity and sentence is a single record. Okay. Input format helps you create records. So this is what input records is. Okay, input split is. So we discussed about how to write MapReduce using Java. Then we discussed about how to customize, how to. So basically, you can extend input split and input format to convince Hadoop to handle to basically form a different kind of input as per your requirement. Okay. Now, so I'm going to go through the diagram once again. So you have got one input split here, one input split here, one input split here on three separate nodes. On each input split, a map is applied. Okay, map is created for each input split. Under each input split, there would be a lot of records. On each record, a map is applied, and whatever output we get is sorted first and then is copied and merged onto one node. This node can be either of this node or could be a fresh node. Right? And after you have copied and merged it, then that is fed to the reduce. Okay, that is fed to the reduce and saved in a file with the name part 0000 something. All right, and goes to the HDFS and replication starts happening. Okay, so this diagram is clear to you guys. Feel free to ask questions. Okay, I mean, the whole objective of these classes is that you can ask questions and I would try my best to answer. Okay, even if it's a very very simple very very simple question, feel free to ask, because I must have missed out something because of which these confusions have arisen. All right, so feel free to ask questions at any moment of time. In case you are not feeling comfortable asking in this class, drop me an email and we can discuss. Okay, drop me an email, we can discuss, you can plan for another session or something if you are really really offset. Okay, offset as in lost lot of concepts. So just drop me an email when we can discuss in person. All right, now, and here, I mean, keep asking questions so that I know that I'm talking sense. And mapper is per split and reducer is per node. No, actually. So mapper is created per split, but that split instance is created, which means the mapper code, whatever you written, loaded into the memory. Now for each record, it will be applied on each node, right? So once you have once it is done sorting, it copies to a central place. In case you have a single reducer, if you have a single reducer, it is copied to a single place, and that is given to the reducer. So reducer is not per node. Reducer is something which is configurable. Okay. Ideally, if your the data is not too big, a single reducer is sufficient. But reducer will be overloaded. That particular machine running reducer will be overloaded, and therefore to it makes sense to run reducers based on how many free nodes you have. Okay, and reducer is a configurable part. Mapper is not configurable. You cannot say that run only 3 mappers or 2 mappers, but reducers is, because reducers can be run on 1 node, 2 node, 3 node, and so on. Okay, a split can have data from multiple nodes. Does node interact with each other to make a split? Exactly, Pranav, you got it right. So there is a small data transmission that happen as I was showing you the boundary. So this much data, this little data between these two lines, this line vertical, these two vertical lines, this is the data transmission happening between the two nodes when they form the input split. Because input split, it requires the whole fifth node, right? And the fifth node portion of it is lying in the sixth node, on the other node. So you'll ask that guy, hey, give me this one, and then you keep it rest of the things. Okay, so that input communication has to happen. Little bit input communication happen, right? So you got it correct. All right. A split can have data from multiple nodes. Okay, perfect, perfect. Now here, the convention is that these strong lines are basically copy the data to the nodes across the cluster, while dashed lines show that there is no local transfer. There is only local transfer. Yes. So yes, it affects the performance a bit because network communication does take a bit of overhead. Even if you're transferring single byte, it has to create a connection. It has to create a connection and then copy the data from here to there. All right. So yes, the performance is impacted a bit over there. Right? So now the other part is that, So by default, there is a reducer one. Now, if you have too many reducers running over there, so you can see that the shuffling job will become, you'll have to shuffle and transfer the data, right? And and then if you have got too few reducer machines, if too few, only there is one, say one reducer machine, that means all of the weight lifting will be done by the single machine and it will be overloaded. Okay. Now I'll just take this slide after this. Now this is multiple reducers. Okay, this is multiple reducers, and this is what happens inside if you have multiple reducers. Okay, I'll explain to you this slide. So up to here it is same story. Up to here it's same story. Now what it is going to do here, if you can see here, it is creating two sections. Okay, we have got say two reducers right now. We've got two reducers, part 1, part 0, part 1. On certain, based on certain heuristics, it will figure out that key 1 to key 100 has to be sent to this one. Key 101 to 100, 200 are sent to this one. Okay, so does a quick it does a quick split of the keys. Based on this split, this quick split between the keys is done by your function. You define how to split the data. Okay, you define how to split the data. So just after sorting, you have two buckets. One bucket goes to this machine, other bucket will go to the other machine, and that happens on all the nodes, right? Now you can see that from a single machine, there are two set of transmission happening to this machine to this machine. And therefore, if you have too many reducer tasks, so these transmissions will be too high. Total number of communications will be too high. Here, instead of 3, now it has become 6. In case there are 3 reducers, there will be total number of communication that happening are 9. Will become 9, right? So similarly, if there are too many reducers, the shuffling is going to be higher. Shuffling as in half of the data is going to this one, half of the data is going to that one. So that is shuffling. Now, how to have multiple reducers and which key needs to go to which node, because if you notice that when we are running a reducer, it is essential that all the values for a key are on the same node, right? Otherwise, that array which we give to reducer saying this array contains all the values for this key will not be complete, right? So all the values with respect to a key should be on a same node. Otherwise, the whole purpose of reducer is defeated, right? And now how do you make sure that the data is splitted uniformly? You can control that part using this one. Say there is something called partitioner. So partitioner's role is to partition the keys onto reducer. Which keys will go to reducer 1, which keys will go to the reducer 2. That is what happens over here, right? That is what happens over here. So this partitioner, you can write your own partitioner. The way I have written something called age partitioner, it extends a partitioner and it says that it returns a number. It returns a number, okay? And based on that number, it is decided that this reducer has to go on which machine, okay? It decides that it has to go to which machine. It say all of these return only 0, which means there will be only a single reducer. If it returns 1, 0 and 1, then there will be two reducers. If it returns 0, 1, 2, then there will be three reducers. Similarly, how many ever you want the reducers, your logic can decide. Okay, so your code called get partition take as input key and the value. Okay, and total number of reducer tasks available right now. Okay, I mean, you know as per the configuration. So if the number of reduced tasks is equals to 0, return 0. If the age of the person, okay, this age is basically, you see, this is the key, and basically key, you can think of it as the age. Okay, let me, okay, so age partitioner. So let's just for time being, let's consider it to be uh, text. Okay, and let's parse it here somewhere. Let's just after parsing this input key, we can do this, right? And similarly, we can have all sorts of conditions, and notice that this essentially means that when we divide total number of tasks, okay, whatever number is coming out, we are just saying divide it. Say had it been 1000, had it been 1000, so 1000, it could have been 1000 divided by, say, number of reducers are 2. So this value will always be less than 2, less than or equal to 2. All right. So what I mean to say is that here, whatever value comes here, 1 or 2, we just saying that we divided by number of available tasks. Okay, and whatever remainder is there. So using this kind of a logic, we can control which key goes to which machine. Okay, that is the role of something called a partitioner in case of Hadoop. So is that clear? What's the role of a partitioner? No? Is it clear to you that what's the role of a partitioner? Partitioner help you control which key goes to which machine, or which key and its values go to which reducer. Do we need to keep changing the partitioner? Yes, based on your need or demand, you might have to change the partitioner. All right. But by default, Hadoop does a decent job. If you have not defined a partitioner, still you can tell Hadoop to use multiple reducers, and then it will do the job. Okay. Only in the circumstances when you are really, really sure that you can divide the keys better than Hadoop will do by default. Only in those circumstances you will be creating partitioner. All right. Only in those circumstances where you are convinced that you can do the job better than Hadoop. Yes, it will affect the performance a bit. A bit performance will be hit, but not visible. I mean, the performance impact will not be too much visible to you. So yes, partitioning depends on data. Yes. So does a splitter, partitioner, multiple reducer is used internally by MapReduce when query is fired from Pig and Hive? Yes. So Pig and Hive both have the internal optimizations for these things. Pig provides you a way to control it, okay, by a syntax in the query, while Hive does not have such a syntax in the query. And probably these optimizations are the reasons why Pig was invented in first place. Okay. So these are Pig uses it internally as well as provides you a way to configure it, while Hive uses it internally but does not let you configure it. So yeah. So is it clear? Basically, all I'm returning is this returns something between 0 to total number of task. It returns a number which is between 0 to total number of tasks. Okay. And basically which dictates that whatever number it gives out, your data, your key will be moving to that particular reducer. All right. Now there is a interesting concept called combiner functions. All right. So combiner functions are an interesting idea, and combiner functions are something like this. So if you remember, we talked about an interesting problem where we were just doing a frequency analysis of alphabets. Okay, only 26 character we need to count. So if you do a standard way saying alphabet A1, Z1, and so on, you keep, all you do is you keep on spitting out character, and then the value character is your key and the value is your number. If you keep on doing that on the same machine, there'll be like a lot of data which can be summarized then and there itself. Because at the end of the whole idea of the frequency analysis of alphabet, there'll be 26 numbers at the end of the whole computation. So there's a lot of scope of reducing the data before it gets transferred to another node. Okay, before it gets sorted and transferred to other node. Okay, we can no matter how big a data it is, you can always bring it down to 26 numbers, because that's what we are interested in, right? And therefore, in the problem where we were computing the frequency of the letters, we can do a summarize, or we can combine a lot of data and minimize the data transfer, right? So it runs on the same node. Okay. So whatever output of your mapper is there, whatever output comes from the mapper is first run through a combiner before sorting the data. So in our diagram, in this diagram, you can think of combiner somewhere here. Okay. So data came from the HDFS, input splits were formed, then the map was called, then whatever output of the map is there, your combiner function is called here, and whatever is the output of the combiner function is then sorted, which means you did a decent job of minimizing the uh, data, and thus your process of summarizing will become really fast. Okay. Now let me show you what does it mean by, okay. And but this does not mean that your mapper replaces your reduce code. Though the signature of a sorry, combiner replaces your reducer code. No, combiner does not replace your reducer code. Instead, it is just a way of minifying the data before getting transferred. Interestingly, this mapper, interestingly, the function signature of a combiner function are exactly similar to the reducer function, right? Because the idea is exactly same. So given a lot of values, the combiner function has to combine all these values on that node itself before the data transfer happening. Okay. Right. Now there is an important aspect of a combiner function. Combiner function has to be associative and cumulative. Combiner function has to be associative and cumulative. What does it mean? No matter in what order and no matter how many of the values are picked at once, right? The output should be same. for a bunch of values, say you have got a huge array, okay? No matter how you are comparing the two values to find out minimum, if you keep on doing it again and again and again and again, finally you will be left with a single value, irrespective of how you are comparing values, right? And therefore, functions like sum, minimum, maximum are called associative and cumulative. Meaning, say you have got 0, 20, 10, 25. No matter how you are computing maximum, you will always get 25 correctly. Now look at this example. One is you do maximum, you first compare 0 and 10 and then 20 and 25, and whatever is the result, you will always get 25, right? Or I'll give you another example. This will be similar to, say, I say here, right? So I say you compare 0 and 10, right? And then 20 and 25, okay? And then you will always get 25. No matter what you do, you will get the right results, okay? Similar is the case with sum. You sum first two values, then these two values or three values first, and then whatever is the result, you combine it with 25, you will always get same result. Right. No matter how many values together or no matter in what order we are applying a function onto these multiple values to return a single value, the outcome is going to be same irrespective of the order and number of values. Okay. So can somebody tell me that is average function cumulative and um, you know associative? So all the combiner functions have to have this property because let's say there is a 1 billion values on a single machine, right? Now it has to combine these values to minify the data before transfer, before sorting, right? So if it can do a sort of some magic by running multiple values through it and then getting to a result, it'll be great, right? Because combiner function has to run on a huge data, say 1 GB, 2 GB, or maybe more, or maybe very less. But it has to run on data, and this is the property they expect, right? So is average suitable for combiner function? Quick. So Ishwar is saying no. And why do you say so? Can somebody give an example why average is not suitable? Let's just run through this one, okay? Say let's just take these two cases and see if we get to the same value or different value. All right, so we say avg. Why I am focusing on this particular function? Because same thing is there in Apache Spark also, so it is must to know kind of thing. So average of 0 and 20 is how much? This one what will you have? 10. Perfect. This one is this value, the one which I'm going to type. Can somebody give quickly? 10 and 25 average. 17.5. Similarly here, now when you do an average of these two values, what do you get? 27.5 divided by 2. 27.5 divided by 2 is how much? 13.75 probably, right? Similarly, average of 0 and 10 is 5. Average of 20 and 25 is how much? 20 and 25 is 22.5 probably. Alright. And here you will get a result of, oh, just a second. Did I mess up somewhere? So 5 plus 22.5 divided by 2. Okay. In this case, it's okay. Now let me just try to change a little bit. Say I say 0, 10, and 20. Okay. And average of 25. And here we get 20 plus 10 is 30. 30 divided by 10 is this one. And average is 25. Okay. And here you get 35 divided by 2 is 17.5. 10 plus 25 divided by 2. Now you got it, right? So we did an average of 0, 10 and 20, which is 10. Then we did an average of 25, a singular value, which is 25 itself. And then we said this. It is coming out to be to 17.5. Why this is 13.75? Now you got the idea why average cannot be the right value? Here, here we did two values at a time. Here we did first three values, then one value, and therefore we got a very different results. So therefore, an average cannot be used as a combiner function, right? Is it clear what is a combiner function and what is not? So let me ask you this. Is say we have got a function, what does it return is function f a comma b, and it returns a, I'm just writing a pseudocode. It returns sqrt of a into a plus b into b. Okay, so or you can say c on so on, and I'm saying c into c. So do you think this function, which basically returns square root of some of the squares of the values, is it a good candidate for combiner function? Can somebody tell? Anybody? Is, why do you say so? So let's take a case here. Square root of 0 square plus 10 square plus 220 square plus square root of 25 square, which is 25, and then this one. Now again these values will be squared, which means under root of this one will go away, and this one will become, and then at the end of it it will be the same, right? Just think about it. Pranav, are you with me? Prasanna, Jagannath? Great. So do you think this function basically returns square root of these squares, some of the squares? So do you think it's appropriate for combiner function? Okay, 1 2 3 as an example, let's take. Should I take an example or you are saying something? So we say 1 plus 2 is 4 plus 3 and 9 13, right? And then square root of this one, and then you sum up first one plus square root of this one, which is 13, square of 30 square root, which is 13. So the output will be square root of 14, right? And same thing is happen if you say 1 square plus 2 square plus 3 square. Okay, 9 plus 4 plus 1 is 14, right? So in either case, whether you execute in this manner function 1 comma function 2 comma 3, it you will always get square root of 14. Okay, right? You got the idea, right? Perfect, perfect. So Pranav, is this clear? Prasanna, Jagannath, should I move on? Because this concept is used very frequently whenever we have to do operation, reduction operation on a data again and again without we knowing how big is the data. Okay, all we need to do is we write this function such that it is associative and cumulative, and then the framework will take any number of records at a time, execute your function, and you'll get the summary. Now, framework doesn't have to worry all the time that uh, you know framework doesn't have to worry all the time, or you know that you will overflow the memory. Therefore, framework can take any number of records and run a combiner on that at in once, and then get the results. So this whole philosophy is used multiple times, right? Similarly, and also when you have to specify combiner, you can specify combiner in your Python job also. Okay, so so you can specify a combiner class, combiner script in Python job also, the streaming job, as well as you can set job.set combiner the way we had set reducer or set mapper class in into our job. Okay, and the signature of this map temperature reducer class will be exactly like your reducer. So that was what is your combiner function. Now let's talk about something called data locality optimization. So as we have been saying from the day zero, that let the data not move. Instead, let the code come to the data and does do the job, right? To ensure that there is something called data locality optimization at Hadoop level. Here, here, the first priority is, so these white ones are the node, these vertical ones are your, these vertical ones is your rack, and this is your whole data center. So you have got a data center which has got three racks. Each rack is having um, 8 nodes. Okay, so there are total 24 nodes and three racks, right? So here you can see that the first priority is to execute this. Blue one is your HDFS block, and this green one is map task. So first priority is that this map task is executed on the same machine as HDFS block. If that is not possible, it although it will be very much possible because you have got three copies of HDFS block at three places. So at least some node will be free. But if that is not free for some reasons, so what it will do is it will try to keep it as close as possible on the same rack, on the same rack. All right. And from the perspective or the of Hadoop, this rack and this rack, although they might be physically separate, sorry, this node and this node, okay, both are connected on the same rack. Physically, they might look separate, but it is equivalent to this one. Okay, even though two nodes are exactly adjacent or very far, but they are on the same rack. Okay, both are equivalent. I'll describe to you in detail why is it so. In case executing a task, map task is not possible on the same rack, here it first tries to do it as much as possible on the same node. Okay, same node. In case that is not possible, in the same rack. In case that is not possible, then it will do across the rack, but not on the different data center. Okay, and then if that is not also possible, then it has to anyway execute your task far away from your uh, HDFS block. Does it make sense to you? Okay, so here is a question for you. Can the reducer take the benefit of data locality optimization? Yes, no? Yeah. So reducer cannot take the benefit of the data locality optimization, because as we saw in the diagram, it's only the map task which is getting executed near to the data. Here, the reducer task, anyway, for reducer task, you have to transfer the data, right? You have to transfer the data invariably. Now, next question is, if you have to store a file with a replication factor of 3, on which all nodes will Hadoop store this file? Anybody? In a separate rack. Mhm. Anybody else? Say it has to store a file with a replication factor of 3. What is going to happen? Okay. So the first copy will be on the local node. Okay. Meaning on the node on which you are connected to, the local one, on which you are located. Like for example, if we are on Hadoop 1 and we are copying the file from Hadoop 1 to HDFS, so first copy will be on the same node, which is Hadoop 1, and the rest of the copies will be on different tracks. Okay, and this logic keeps on changing every now and then, but the sole idea behind keeping one copy here and another copy on another rack altogether makes it the redundancy really reliable. In case something wrong with one rack, there is something else waiting for us. Okay. Basically, in case one rack goes haywire, we have got other two racks, different one, from where we can use our data. Okay. Now, this is a common question which people ask. We had been talking about data locality optimization, this, that, but how does Hadoop decides upon data locality? Okay. Or data locality optimization is also known as your rack awareness. Okay, rack awareness. So ideally, whenever you set up a network, you have got a switch, you have got rack 1, you've got rack 2, and you have got these nodes, right? Okay, so this is more like a tree, right? This is more like a tree. Now, exactly whatever visual representation you have, you tell it to our Hadoop that this is my tree. Okay, IP address this one, IP address this one, IP address this one, IP address this one. This is the tree structure that exists. Okay, so we call it server one, switch one slash rack one slash node one, right? And similarly, the way file structure is, right? So we represent the nodes into file structure. Okay, so the idea is that there is a shell script which you can configure in Hadoop, saying, hey, this is my shell script which will convert an IP address into sort of a tree like this, like file. Okay, and the most common way of defining your data network is by replacing dot in the IP address with a slash. Okay, which means 192.168.1.1 will become 192 slash 168 slash 1 slash 1. Okay, so that's also a way people do a lot to tell Hadoop, hey, this is how my network laid out. Give me so this script will so Hadoop will ask your script, this is the IP address. Tell me in the form of a path, the where does it look is located. So the any network topology can be converted into that. All right. So rack awareness or data locality optimization is both the same thing. It is similar to file path in the sense that we represented slash a slash b slash c. DNS to switch mapping provides the translation from machine name to key location. In the configuration of Hadoop in etc slash Hadoop slash Hadoop dot XML, there is a key called topology script dot file dot name in which you can define your shell script which can convert any IP address into this kind of path. Okay. Now, distance between two paths are computed in this manner. Some of the distance is from common ancestor. Okay. Now, let me show you how. Some of the distance is from common ancestor. Now, let me ask you. So, the distance between this node, okay, this is my D1, this is my R1, this is my node 1. So, distance between node 1 and node 1 itself on the same node, what will be the distance quickly? Or you can I can ask you this. Okay, right, all right. So are these numbers correct? Okay, let's just do the recomputation. So you can tell me that distance between node 1 and node 1 itself is how much? 0, right? Perfect. Perfect. Similarly, the distance between node 1 and node 2. So how are we computing node 1 and node 2? Is node 1 and node 2 is node 1 is represented as this path and node 2 is represented as this path. All right. Now their common ancestor is how much? What is their common ancestor? R1. Okay. So if you have to go from node 1 to node 2, you will have to go to their common ancestor R1 and then come back. Or you can say node 1, you rack 1 and node 2. So how much is this distance? Quickly. Went to here, then come back to here. It's not 3 enough. So I mean the way it is computed is the distance to both the nodes. Yes, it is 2. Good, good. And similarly, node 1 and node 3, how much? Perfect, perfect. Right. So it'll be 2. Now, node 4 and node 1. Anybody quickly? Node 1 and node 4. 1, 2, 3, 4. Perfect, perfect. Right? So that's how it is computed. All right. So from IP, if you give out, this path to Hadoop, Hadoop can figure out the distance. The way we have just computed the distance, Hadoop will also compute the distance in the same fashion. Right. And node 1 to node 4. Node 1. Okay, here it is not there. We have got two data centers here. Okay, so we go from node 1 to node 2 1, node this one to this one, node 1, and then there is a one more level above this one. So 3 plus 3 is 6. Okay, so basically 6 is in this case. So everybody got how is this data locality optimization is done or rack awareness is done? Great, great. So that is pretty much for today. It's pretty much for today. And let's try to solve this problem of executing tomorrow again. All right. And do you have any questions right now? Great. So you don't have any questions. So let's finish the class here itself today, and then we'll take up rest of the things tomorrow. Tomorrow we are going to discuss. First, we will give a demonstration on of Java Hadoop, a Hadoop job, MapReduce job, and then we will talk about Pig. So Pig is what we are going to start tomorrow. All right. So any questions from your side? Is everything clear or so any assignment for today? I mean, not much of an assignment for today. You finished the assignment of the previous class. The only assignment I had for today was to run the Java code in Eclipse and then upload it on the server and run it over there. That was the assignment, and that is the assignment for today. That's all. Okay. So whatever the Java code is there, you're supposed to run that one on the server, and then we try out. So yeah, great. So I mean, finish all your assignment and let me know. Okay, in case you're stuck, you're not able to solve a problem, let us know. We will be able to help you out. Okay. Thank you, Pranav. Thank you, Jagannath. Thank you, Prasanna. Thank you, Iswar. Good night, guys, and have a good day tomorrow. Yeah, good night.